So in this problem, we're supposed to dim a picture, kind of like in the Udacity video. So that was the video here.
Mary, let's slightly dim this picture by turning every fifth pixel black. You saw how to use the pixels method to get the number of pixels, and how to use the setPixelAt method to change the color of a pixel. You'll need a...
So the methods that Sarah is referring to are over here in the picture API. So there is a getColorAt that gets you the ith color that she didn't actually mention. I guess because she didn't need to, because in that assignment one didn't need to know what the color was. One just overrode what was there. Here's the pixels method that gets the total number of pixels, and then there's the setColorAt. Now, when you look very carefully, you'll notice that there's two methods called setColorAt, and only one of them is the one that's being used in this video. And so the expectation was that you would use the one that's in the video, and that's the one that takes a single integer index. So the idea is that if you have this picture here, that I goes from 0 to a very large number, and each time one pixel row here gets scanned through, and after lots and lots of pixels, eventually we would be picking up the last pixel here. So that would be getPixel of I, and then we would call setPixel of I with a new color to modify the color that's in there. So how do we modify the color? Well, we need to take the existing color and somehow make it darker. And the darkness depends on where it appears, in which column it appears. So we do need to figure out how do we get the column of one of these. And so there was a bit of a hint, but let's work through this just from the beginning so you can see where the hint came from. And so we'll just assume that the picture is small. Right now, just to get the number straight, we'll just say it was a 10 by 10 picture. So in this case, I would go from 0 up to 99 to pick out these pixels. So how do we know the column? Well, let's take a typical pixel here. So this is 10, 11, 12, 13. Let's look at 13 here. So which column is it in? Well, it's in column 3, of course. So in general, if you have I, then I mod 10 is the column. And where did the 10 come from? Well, that was the width. So for us, I mod 10 is going to matter. Sorry, I mod the width is going to matter. And that's the column that we're interested in. And now we need to figure out how does that dimming work. So the general assignment said that what we're supposed to be doing is multiply with some factors. So it says that we should be multiplying with these factors. So it said the leftmost column we should multiply by 1. Then we should multiply by a factor f1 times a factor f2 times a factor f3 and so on. And all the way at the end, the factor should be 0. So when you look at it, so how many factors do we have? Well, we have as many factors as we have columns. That's given by the width. So in our case, what should those factors be? The last one should be 0. We know that one. The one over here, should it be 1/10? Well, let's try that. Then this would be 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. That did not work, because 9/10 here is not what we want, which is 1. And so if you think about it, there are 10 numbers there, but there are 9 steps. There's one less step than a number. So what I shouldn't be dividing by 10. What I should be doing is I should take 0, 1 ninth, 2 ninth, 3 ninth, 4 ninth, 5 ninth, 6 ninth, 7 ninth, 8 ninth, and hooray, 9 ninth, because that is 1. And now I'm good. So in general, going from the right to the left, what I have is sum k times k over width minus 1, and that's my factor. And what is k? Well, let's see. K is 9 at the leftmost one, so when I is 0, and it is 0 all the way at the right when I is 9. So clearly k is 9 minus I. And where does the 9 come from? Well, that's again width minus 1. So it's width minus 1 minus I. So over here I can replace k by width minus 1 minus I divided by width minus 1. And that is my ith factor. And it's of course crucially important that one gets these minus 1s here right. And notice how I discovered these. I didn't do what they tell you to do in a math class to think through this logically. I simply took a specific example. I said, let the width of the picture be 10. Do it with 10 pixels. And that way I got some intuition to see what was going on. And then later, after I had the intuition, then I figured out what it works out for a general width. All right. So now in the code, there is now no further surprise. The factor is over here. So here is my column. And I just put that right in here. I didn't even bother to make an extra step. Notice the times 1.0. That is one final nitpickiness here. Over here, this quantity is an integer. This quantity is an integer. I can't simply divide two integers because then the result would in this case always be 0, since integer division truncates the remainder. The cheapest way of converting from an integer to a floating point number is to just multiply with 1.0. And then the rest is, I believe I've given this to you, where you simply multiply each of the coordinates, or each of the green, red, blue values by the factor. Then somewhat unhappily you need to put it back into an int because factor was a double, so the thing inside parentheses here is a double, and the color constructor requires ints. And when you do that, you will indeed get the right picture. Here it comes.